Hi everybody, this tutorial is to help you figure out how to do metric conversion problems in chemistry. Like I said in class, this is the way I explain it, so you can do these problems in a slightly different way, putting numbers in different places, but the setup is always going to be the same for your problems. We're going to start with an example that doesn't use metric units, just so that you see the pattern that we're using with the units. So this problem asks you to convert 2.0 yards into inches. So as always, the first thing that you need to do is put what's given to you in the problem as a fraction over 1. And I do that just so that my first step is in the form of a fraction, because every step after that is also in the form of a fraction. Now, the next thing that you should always do is take the units that you have up here, in this case yards, and we need to cancel them out. So mathematically, to do that, you take these units that were at the top of your fraction and you move them to the bottom of a new fraction. That should always be your first step. Always fill your units in first. Now, that will cancel out yards. And then on the top of the fraction, you have to decide what units are you allowed to, or what units do you know how to convert to. So in this case, I think most people know the conversion between yards and feet. So that's how you know the units that go on top. After you have your units filled in, you can see that yards cancel and you're left with feet. And now you can fill in the numbers. So this is something that you do in the metric conversions as well. Our brains like to think about how many littler units fit into a bigger unit. And that's why we know that for every 3 feet, that's the equivalent of 1 yard, because 1 is the bigger unit. Now the problem asks you for inches, but right now we still have feet. So that means that we need another fraction bar, because we need to cancel feet out by bringing them to the bottom of the fraction. Now from feet, I think everybody knows for sure the conversion from feet to inches. So now that you know that those are your units you need, you can see that feet cancel and you can fill in your numbers. So again, the bigger unit is feet. So we're going to say 1 foot is equal to 12 inches. And then from here, you're ready to solve out your problem. And in this tutorial, I'm not going to actually do the math. I'll explain it, but you can kind of figure out the answer just by plugging into your calculator. So the important thing here is how you set up your work. Now, how does this relate to metric conversions is that you need to know those powers of 10 that are in your packet. If you don't know those powers of 10, make yourself some flashcards and just sit down and learn them. Alright, so this problem asks you to convert 3.20 centimeters to kilometers. If you don't know the powers of 10, you might find it helpful to have your packet with you while you watch the tutorial, so you may want to pause and get your packet out and have that near you. Okay, first step, put what's given to you as a fraction over 1. So you have 3.20 centimeters over 1. And again, we're only putting it over 1 because every step after this is a fraction. Okay, so just like in the last problem, the first thing you always must do is take the units from the top of the fraction and move them down to the bottom so that they cancel out. And that way, you know that algebraically you're doing the right steps. So centimeters move down. Now, with doing metric prefixes, the way that those powers of 10 in your table are designed is so that you can go from a prefix back and forth to no prefix. Ignore the fact that I didn't leave a space between the word no and prefix. Space. Okay, so prefix to no prefix, or if you have no prefix, you can add a prefix. So what that means is on the same fraction bar, you shouldn't see two prefixes. So if you right away saw centimeters and said, okay, I need to get to kilometers, this is a problem because of the fact that you have units on both fractions. So you have centi here and you have killi here. That's not a good thing. So the idea here is that since you have a prefix at the bottom, you cannot have a prefix at the top. So this should be just meters at the top of your fraction. Okay, now this is where you need to know a power of 10. The rule is that you will always use a 1 beside the larger unit. So in this case, a meter is larger than a centimeter, so we fill in a 1 beside that. After that, we'd fill in the power of 10 that goes with the prefix for centi. So if you don't know that, you can see in your packet that centi is 10 squared, which really just means 100. So what this actually means is that there are 10 squared centimeters equals 1 meter. That's what you're telling me. So you can kind of do a check to see if your conversion makes sense. Okay, so right now centimeters cancel, but those aren't the units that we want. We don't want meters as our final unit, so we need to do another step. To get rid of meters, we have to bring them down to the next fraction. And now, since meters doesn't have a prefix, now it's okay to add 1 back on to the top. So from meters, you are allowed to go to kilometers. And now you fill in your 1 and your power of 10. Now, this is where you really have to pay attention to what's going on. The rule is, again, that the 1 will always be beside the larger unit of the two that are on your fractions. So, in this case, a kilometer is larger than a meter. So you are forced to put the 1 at the top of the fraction because our brains want to think, how many meters are in 1 kilometer? That's what we're trying to figure out. How many of the smaller thing fit into the bigger thing? Now, you must still use the power of 10 that goes with kilo. It's just that you're going to be filling it in on the bottom of the fraction. So the power of 10 doesn't necessarily always go next to the prefix, but if your prefix is kilo, no matter where it is, you have to use the power of 10 that goes with that prefix. So the power of 10 for kilo is 10 to the third. So again, what this fraction actually means, 10 to the third is 1,000. So you're telling me by writing this step that 1,000 meters equals 1 kilometer. And that should make sense. If you had reversed the 1 and the power of 10, then you would be really telling me that, so if your last step, instead of it looking like this, if you moved meters down and put kilometers at the top, let's say that you said, okay, well, kilo is 10 to the third, and then I need a 1 somewhere. This step really tells me that there are 1,000 kilometers in 1 meter, and we absolutely know that this is completely false and not true. So you can always do a little check to see if your thinking is correct. Okay, now from here you would have to plug into your calculator. Again, the numbers that you're trying to record are the numbers that are not ones. So the 3.20, the 10 to the second, and the 10 to the third. So this is where you would say, okay, these values are all on the bottom of the fraction. So you should do 3.20 divided by 10 to the second, divided by 10 to the third, and that way you don't have to use any parentheses or anything like that. And that is how you would solve that problem. Okay, we have two more examples, and I'm going to go through those a little bit quicker. If you're still confused on this example, I might watch this part again before moving on to the next two. Okay, this is an example where your units that you're starting out with are already a fraction. We did one like this in class, but here is another example. When you see a problem where your units start as a fraction, you want to avoid doing this. You would not want to see that. Because in this problem, then you have two fraction bars right away, and that makes life confusing. So what you really want to do is start out, let me see if I can erase. What you really want to do is use that original fraction bar to your advantage. So whenever you do your 100 kilometers, put that over 1 hour. So this fraction bar in your units is really now this fraction bar in your first step. So the only time you should ever have units at the bottom of your first step like this is if there are fractions in your original units. Okay, so from here, the task that you need to be able to do is to convert from kilometers to meters, then from hours to seconds. So there are two parts. Out of habit, I tend to always work with my top units first because I know to eliminate them and get to my new units, I'm going to have to bring them down to the bottom of the fraction so that they cancel. Now, since kilo has a prefix on the top of the fraction, that means I'm allowed to go from kilometers to just regular meters. Now that I have my units in place, I can fill in the numbers. Kilometer is the larger unit, so it will receive a 1, and the power of 10 that goes with kilo is 10 to the third. So 1,000 meters, 1 kilometer, that makes sense, so I can move on. Now, at this point, you want to see meters at the top of your fraction, and there they are. So that's how you know this conversion from kilometers to meters is complete. Now we need to convert the hours. So the hours start out on the bottom of the fraction. So in another fraction over here, to get hours to cancel, you simply move them to the top instead. Because if they're on the bottom of one fraction and the top of another fraction, they cancel. Now, this is again not using the powers of 10, but I think we are all pretty clear on the conversions that we need because everybody knows how many hours relate to minutes, because we all know that in 1 hour there are 60 minutes. But minutes aren't the final units that we're being asked for, so we need to do one more step. We're being asked to go all the way to seconds. So I'm left right now with minutes on the bottom. I don't want that. So that's how we know, okay, we need another step, and minutes this time will move up to the top so that they cancel. And now you also know the conversion between minutes and seconds, because for every 1 minute there are 60 seconds. Okay, so again, the numbers that we're concerned with are the things that are not ones. So when you plug this into your calculator, you would do 100 times 10 to the third, since it's on the top, then divided by 60, divided by 60. So anytime a number is on the top of the fraction, you multiply. Anytime that it's on the bottom, you divide. So that's how you work through an example where your units start as a fraction. Okay, one last example here is dealing with what to do when your units are raised to an exponent. So the one thing that you want to remember is that whenever your units are either cubed or squared, in this case, you're dealing with a cubic centimeter, which, remember that little tiny yellow block from class, it's a measure of volume. So those powers of 10 only work in one dimension, not two, not three, only one dimension. So this is an example similar to one that we did in class, where I had said, take your value, and instead of writing centimeters cubed, expand this out so that you see centimeters times centimeters times centimeters, and then put all of that over 1. Now, to get to meters cubed, here's what you have to do, and this is why I suggest you do this. We have to cancel out all 3 of those centimeters. So the first step I'm going to do is, obviously, I need a new fraction. And this first centimeters, that's the only one I can deal with right now. So I'm going to move it down. And I know that I can convert from a prefix to no prefix. So from centimeters to meters. And the 1 goes with the larger unit, which is meters. The power of 10 for centi is 10 to the second. So at this point, this set of centimeters is the only one that cancels. So that means that from here, I need to cancel out my second centimeters. So I need another fraction. These centimeters in red move down. And you know from centimeters, you can get to meters. And just like the one before, for every 1 meter, that's 10 to the second centimeters. And now these cancel. But there's still one more set that needs to be taken care of. So now this third centimeter, it will come to the bottom of a fraction. And now we can convert it to meters. And same as before, every 1 meter is 10 to the second centimeters. So this is the method that is most likely going to give you the correct answer, because you're not as likely to forget to cancel out all 3 of these centimeters that you're starting with. So in this case, you would type in 50 divided by 10 squared, divided by 10 squared, divided by 10 squared, and that would give you your final answer. So I hope that this tutorial has helped clear up any confusion about unit conversions. After watching the tutorial, if you still have questions, please feel free to come in with specific items that you are still having trouble with, so that we can go over those specific items.